Hi, in this video we're going to have a look at A-Level Further Mathematics past paper from May-June 2022 exam series. Let's have a look at the very first question. Okay, we'll have to use the method of differences to find the sum. So first of all, I will try and find the difference of the two fractions. I'm going to combine them together and use the common denominator. So 1 and minus 1 will cancel out. AR minus AR also cancels out, and I got A over AR plus 1 times AR plus A plus 1. Okay, and as we can see, this result is almost identical to what I've got in the question, apart from the fact that I got A in the numerator and I should be getting 1. So to make it absolutely identical, I will have to divide this by A. So I will simply introduce 1 over A next to the difference. And now we can use the method of difference to find the summation. So it's going to be 1 over A, and because A is a constant, I will take it out of the sum. And I got 1 over AR plus 1 minus 1 over AR plus A plus 1. Now, let's substitute 1 into R and see what happens. Put 1 over A plus 1 minus 1 over 2A plus 1. So that's when R equals to 1. Let's substitute R equals to 2 and see what's happening. Minus 1 over 3A plus 1. So we can see that we already have some terms cancelling out. So dot dot dot, let's skip a few, and the very last one is going to be when R equals to n, and that will be 1 over an plus 1 minus 1 over an plus a plus 1, and this fraction will also cancel out with something in the dot dot dot. So these two are when R equals to n. So what is left is 1 over A, then the first fraction, 1 over A plus 1 minus 1 over an plus A plus 1. That will be my answer for the first question. Okay, let's have a look at the next one. We have to find the value of A for which the sum to infinity is 1 over 6. Now, if you look at our answer from the previous question, we can see that the second fraction, where we have 1 over an plus A plus 1, will turn into 0 when n tends towards the infinity. And what is left is 1 over A times 1 over A plus 1 equals to 1 over 6. So now I can multiply the fractions and I will get 1 over A squared plus A equals to 1 over 6. Okay, so from here, let's flip both fractions over to get A squared plus A equals to 6. That's simple quadratics, and get A squared plus A take away 6 equals to 0, and we can factorize and get A plus 3 times A minus 2 equals 0, so therefore A is either negative 3 or A is positive 2. Now, if you look at the question, it says A should be a positive constant, so therefore it's A equals to 2. That's the final answer. Okay, next question is about vectors. And first of all, I'll just write everything using column vectors. So vector OA would be 4 minus 4 and 1. Vector OB minus 4, 3 and negative 4. And then vector OC is 4 minus 1 minus 2. Then also I want to draw a quick sketch just to understand better what's going on. We have a plane, we have the origin somewhere, and we got 3 points on this plane, A, B, and C. And we should find the equation of this plane. Now, first of all, we're going to have to find the normal vector of this plane. And to do so, we can find a cross product of any two vectors on the plane. I'm going to use vector AB and vector AC. So first of all, I'll have to find them. Vector AB is going to be -8, 7, and -5. Vector AC will be 0, 3, and -3. Okay, now the dot product, cross product and AC should be the determinant of this matrix. I, J, and K. Now the first vector is -8, 7, -5. The second, 0, 3, -3. Okay, let's calculate the determinant. So it's going to be I times -21 plus 15. Don't forget to put a minus next to J, and 24. Just 24. And then plus K times -24 minus 0. And that gives us -6I minus 24J, and then minus 24K. Okay, and also just because I'm looking for the direction of the normal vector, I don't actually need the magnitude. I'm going to divide everything by -6 and say that the normal vector is 1, 4, and 4. Okay, so now we have a normal vector of the plane, and to find the equation of that plane, I would say, okay, let's have a new point on this plane with the coordinates x, y, and z. And now again, any vector on this plane containing the point P should be perpendicular to n. And let's use the vector AP, for example. Because AP is perpendicular to the normal vector of this plane, that means that the dot product should be equal to 0. And that's how I'm going to find the equation of the plane. I will say AP dot n should be equal to 0. So first of all, let's find AP. That's going to be x minus 4, y plus 4, and z minus 1. And then dot product with the normal vector 1, 4, and 4. That gives us 0. Now let's find the actual dot product. X minus 4 plus 4 times y plus 4 plus 4 times z minus 1 equals to 0. Now let's expand the brackets and simplify a little bit. And we get x plus 4y plus 4z equals to minus 8. For the next question, we just only have to remember the formula for the distance from the point to the plane, which is absolute value of ax plus by plus cz plus d over the square root of a squared plus b squared plus c squared, where x, y, and z are the coordinates of the point, the distance from the plane I'm looking for. And in our case, that's the point O with coordinates 0, 0, 0. So it means our distance is going to be equal to absolute value of d over the square root of a squared plus b squared plus c squared. And now we can use the equation of our plane. So d equals to 8 over the square root of 1 squared plus 4 squared plus another 4 squared. And it's 8 over the square root of 33. That's the final answer. Next question, we have some point D. Let's draw the origin here. And we also have our plane. Find the coordinates of the point of the intersection of the line OD with the plane OBC. Let's draw how it looks like. That's our intersection, and we're going to call it P. Okay, so first of all, vector OD is going to be 2, 3, and -3. And remember, the equation of our plane is x plus 4y plus 4z equals to -8. Okay, so now what I want to do is to find the vector equation of the line OD. Right, so first of all, I need to find a position vector of any point on this plane. Oh, sorry, on this line. And for that purpose, I will use point O because it's 0, 0, 0. So no need to add anything. Apart from lambda times any vector along this line. And I will use vector OD, of course. 2, 3, -3. Okay, now, so for the point P, there is a specific value of lambda which I'm looking for. That gives me the position vector of OP. It's going to be 2 lambda, 3 lambda, -3 lambda. And now because the point P is not only on the line OD, but also belongs to the plane, that means I can substitute coordinates of P into the equation of my plane. That means 2 lambda plus 4 times 3 lambda plus 4 times -3 lambda should be equal to -8. And from here, I can find the value of lambda. Let's simplify that a little bit. That means 2 lambda equals to -8 or lambda equals to -4. Okay, now let's substitute this value of lambda into vector OP. Basically here. And we'll get OP equals to -8, -12, and +12. That's the answer. Okay, in the next question we have a sequence, and we'll have to prove by mathematical induction that any term of the sequence is bigger than 4. So first of all, of course, we'll consider the base case. So when n equals to 1, the first term of the sequence should be bigger than 4. And that is given in the question already. So it's true. Now the second step of our proof is going to be assumption. We're going to assume that for some value of n, and I will say that assume that for n equals to k, holds u k is bigger than 4. Okay, now, what do I actually have to prove? I need to prove that u k plus 1 should be also bigger than 4. is also bigger than 4. Okay, that means we can prove that uk plus 1 take away 4 is bigger than 0, and that's why they tell us in the question by considering un plus 1 minus 4. Now, let's focus on uk plus 1 minus 4. We have a formula for the next term of the sequence, and that is uk squared plus uk plus 12 over 2uk, and then take away 4. And then I will combine this into a single fraction and see what I can get from there. So that means I'll have to multiply 4 by 2uk. That will be minus 8uk. And the common denominator becomes 2uk. Okay, now let's simplify this and we'll get uk squared. uk minus 8uk is going to be minus 7uk plus 12 over 2uk. Now remember, I have to prove that this is bigger than 0. I can try to factorize the quadratics on top and see what I can get. So it's going to be 2 brackets, uk and then uk over 2uk. Okay, now I need the two numbers with the product of 12 and the sum of negative 7. So both of them should be negative. And those numbers are, of course, 3 and 4. Now, let's analyze what's going on there. We know that by assumption, uk is bigger than 4. So that means this bracket, uk take away 4, is bigger than 0. We also know that if uk minus 4 is bigger than 0, then, of course, uk take away 3 is also going to be bigger than 0. And by the same reason, if we assume that uk minus 4 is bigger than 0, right? That means uk is bigger than 4. So, of course, automatically uk is also going to be bigger than 4. So that means we have a positive number on top times another positive number over positive number. So altogether, that is going to be bigger than 0. Okay, so that's actually what I had to prove, and the only step I have left is to write the conclusion. I will say therefore, by mathematical induction, un is bigger than 4 for any n. That's it. Okay, next question. I have to show that un plus 1 is smaller than un. And I will use a very similar technique to what I've used in question A. I will consider the difference between un plus 1 minus un. Let's use the formula for un plus 1, which is un squared plus un plus 12 over 2un minus un over 1. Again, we need a common denominator. Which is going to be 2un, so I will have to multiply this fraction by 2un, and I will get minus 2un squared. Okay, over 2un. Let's simplify it, and I'll get minus un squared plus un plus 12 over 2un. Okay, now let's put the minus in front of the fraction, and we'll get un squared minus un minus 12 over 2un. And same as before, I will try to factorize the top. Two brackets, un and another un. And now I need the two numbers with the product of -12 and the sum of a -1. And those numbers are going to be -4 and +3. Took me a bit longer than it should. Okay, so now we know that un is bigger than 4. So that means un minus 4 is bigger than 0. And of course, if un is bigger than 4, that means un is bigger than 0. So I'll say this guy is bigger than 0. The bracket is bigger than 0. And because un is bigger than 4, that means un plus 3 is also bigger than 4. So the whole fraction is positive, and we have a minus sign in front of the fraction. So that means it's smaller than 0. Okay, so un plus 1 minus un smaller than 0. And that means, therefore, un plus 1 is smaller than un. Right, we have the equation which has the roots alpha, beta, and gamma. And we're looking for a new equation, so probably we're going to use a new variable, let's say y. And then the roots of the equation should be 1 over the root of the previous equation. So that means I can just use a substitution. Y equals to 1 over x cubed. I will make x the subject. So x equals to a cube root of 1 over y, or we can write it as x equals to y to the power of -3rd. And now I'm going to actually make the substitution. So 2 times y to the power of -1 over 3 cubed plus 5 y the third squared minus 6 equals to 0. And then let's simplify that a little bit. Now, at this step, I'm going to get rid of negative indices by multiplying everything by y. So get 2y plus 5y to the power of a third minus 6y equals to 0. That's not a cubic equation yet. So what I'm going to do is to leave y to the power of a third on the left side. And then everything else will go to the other side. Now remember, y to the power of a third means a cube root of y. How can I get rid of a cube root? Obviously, I'm going to cube both sides. 125y equals to 216y cubed minus 216y squared plus 72y minus 8. And now all we have to do is to move this 125y from the left side to the right side. And we'll get the final answer. 216y cubed minus 216y squared minus 53y minus 8 equals to 0. Finished. Next question. So basically what it says is that we have to find the sum of squares of the equation we got in part A. And to do so, I will first divide our equation by 216, and I will show you why do so in the first place. So it's y cubed minus y squared minus 53 over 216 minus 8 over 216 equals to 0. Okay, so now we're looking for this sum of the squares of the roots of this equation. Now let's call the roots alpha, beta, and gamma again. Now imagine you have alpha plus beta plus gamma. So that's basically the sum of the roots of this equation, and I want to square it. Let's quickly try to understand what's happening here. So when you expand those brackets, you'll get alpha squared plus beta squared plus gamma squared. And then you will have also alpha beta plus alpha gamma plus beta alpha plus beta gamma, and so on and so forth. So basically that's going to be twice the combination of alpha and beta, alpha and gamma. I will call this as alpha beta. So that means on the left side we have the sum of the roots squared equals to the sum of squares plus 2 the sum of alpha beta. And from here we can find the sum of alpha just by rearranging. So it's the sum of alpha squared minus 2 times the sum of alpha beta. And just by looking at the coefficients of the equation on top, we can determine some values. And what is super important in here is that the number in front of the highest power of your variable should be 1. So that's why I divided this by 216 in the first place, because otherwise it's easy to forget. So what's the connection between the coefficients and the sum of alpha beta, and so on and so forth? So if you take the number next to y squared with a negative sign, that should give you the sum of the roots of the equation. So the sum of alpha is going to be equal to, remember, I have to take it with the negative sign. So it's going to be minus 1. So basically that equals to positive 1. The next coefficient is going to be the sum of alpha beta, and you will have to take it with a positive sign. So it's plus minus 53 over 216. And finally, the last number, again taken with a negative sign, would be the sum of alpha, beta, gamma. That should be positive 8 over 216. We actually don't need it. Right, we're looking for the sum of alpha squared. We already know what the sum of alpha is. It's 1. So it's 1 squared minus 2 times the sum of alpha beta, that is negative 53 over 216. And if we simplify that, we'll get the final answer, which is 161 over 108. Let's put it somewhere here. Okay, now the next question is basically asking us to find the sum of cubes, the root of the equation in part A. I'm going to copy the equation in the first place, 216 y cubed minus 216 y squared minus 53 y minus 8 equals to 0. And I will say that this equation has roots alpha, beta, and gamma. And I'm looking for the sum of alpha cubed. Okay, now consider this. The equation has roots alpha, beta, and gamma, so that means I can substitute alpha, beta, and gamma into that equation. So I have 216 alpha cubed minus 216 alpha squared, and so on and so forth. And I can do the same with beta as well. I can do similar stuff with gamma. And now I can add up all these equations together. So I will get 216 times the sum of cubes minus 216 the sum of squares minus 53 just the sum of the roots minus 8 times 3, which is 24. And that equals to 0. Remember, I'm looking for the sum of cubes. So I can make the sum of cube the subject of this formula. The sum of alpha cubed equals to 216, the sum of alpha squared, plus 53, sum of alpha, plus 24 over 216. Now, in the previous question, I've already explained what the sum of squares is, and so on and so forth. So we can just substitute those results into our formula. So it's going to be 216 times 161 over 108 plus 53 times 1 plus 24 over 216. And that is 133 over 72. And this shall be the final answer. All right, next question is about graphs. The first one, I will have to show that the curve has no vertical asymptotes. Okay, so how can we find vertical asymptotes? They appear if we divide by 0. So basically that means that x squared plus x plus 1 must be equal to 0 to find the vertical asymptote. Okay, that's quadratics. Okay, let's find x. It's minus 1 plus or minus square root of b squared minus 4ac, 1 minus 4, over 2. And this, of course, has no solutions because 1 minus 4 is smaller than 0, so we have no solutions. No solutions, so no vertical asymptotes. Okay, for the next one, we'll have to find the equation of the horizontal asymptote. And to do so, I will first perform the division. X squared plus x plus 1. Okay, I will first multiply by 2. I get 2x squared plus 2x plus 2. Subtract them. I will get minus 3x minus 3. Okay, so all in all, my equation of the curve looks like 2 minus 3x plus 3 over x squared plus x plus 1. Okay, now if x tends towards the infinity, basically that's what happens if I'm trying to find a horizontal asymptote, then this fraction tends towards 0. So we're left with y equals to 2. That's going to be our horizontal asymptote. Okay, next question, find the coordinates of stationary points. And we can find those coordinates by finding the derivative and then setting it up to 0. Now just quickly copy the equation of the curve, which is y equals to 2x squared minus x minus 1 over x squared plus x plus 1. And to find the derivative, I'm going to use the quotient rule. So it's u over v derivative, which is u derivative v minus v derivative u over v squared. Okay, let's go. U derivative is going to be 4x minus 1 times the denominator minus derivative of a denominator, which is 2x plus 1 times the numerator over the denominator squared. Alright, now it's time to simplify. Expand the brackets, 4x cubed plus 4x squared plus 4x minus x squared minus x minus 1. Again, minus. Okay, so now simplify all of that, and we will get 3x squared plus 6x over x squared plus x plus 1 squared. Okay, and that should be equal to 0. Now, we don't really have to worry about the denominator, because in the previous question, we've already seen that it never equals to 0. So we just only set 3x squared plus 6x equals to 0. Let's divide by 3, get x squared plus 2x is 0. Factorize. And we get 2 x coordinates of the stationary point. So it's minus 2 and 0. Now, time for y coordinates. I will have to substitute x equals to 0 into y. So y of 0 is going to be minus 1, and substitute negative 2. You will get 3. That's technically the answer already. 0, minus 1, and minus 2, 3. Alright, next question is sketch, and we'll have to state coordinates of intersection with the axis. Let me again quickly copy the equation of our curve, which is 2x squared minus x minus 1 over x squared plus x plus 1. Let's start with the easiest one and find y of 0. That's going to be minus 1. So let's intersection with y axis. 0, minus 1. Let's find the intersection with x-axis. That happens if y equals to 0. That means the numerator of the fraction must be equal to 0. That's quadratics. Let's use the quadratic formula. 1 plus or minus square root of b squared 1 minus 4c 8 divided by 2a, which is 4. And we get 1 or negative half. Okay, so our points are going to be minus 1 over 2 and 0. And 1, 0. Okay, time for a sketch. So first of all, the asymptote. We know it's y equals to 2. Okay, next I will mark intersection with axis. I got 0, minus 1, so it's the first point. Next we've got 1, 0 here, and minus half 0. Okay, and our stationary points. 0, minus 1 Okay, so intersection with y-axis is actually a stationary point. And another point is -2 and 3, which is somewhere here. Right, so when x tends towards the positive infinity, we should get closer and closer to our asymptote. And we can never go above the asymptote in that case, because we don't have any stationary points. Now, this situation is a bit different for negative values of x. Why? Because one of the stationary points is -2, 3. So first we actually go above the asymptote. And now when x tends towards -infinity, we should approach the horizontal asymptote from above. So our graph looks like this. Let's actually mark our key points just in case. It's -2. This is 3. And the asymptote is y equals to 2. Okay, I think that's good enough. Okay, next question. Basically the same curve, but only taken with the absolute value. Now, what it does is it's going to reflect the negative part of the curve, where we go below x-axis, on top. So let's quickly draw this. X, y, we also need our asymptote, y equals to 2. Okay, we got a stationary point there. Approaching the asymptote, so pretty much the same as before. And now this part in the middle, look at that, between -0.5 and 1, should be reflected on x-axis. So it should look like that. And instead of -1, we have +1. Now the question says, find the set of values of k for which the equation, the curve equals to k, has 4 distinct real solutions. So basically that's going to happen when we have 4 intersections with a horizontal line. For example, it could be something similar to that. Right, so we have 4 points of intersection. And that might happen if k is in between 0 and 1. Now that doesn't count 1 and 0. So k should be bigger than 0 or smaller than 1. If that's the case, we'll have exactly 4 intersections. Okay, next question, polar coordinates, and we'll have to sketch the curve. And first of all, I will make sure that I take the square root. So it's going to be a square root of inverse tangent theta over 2. Now, so what I'm going to do is just to draw a table. So theta is going to be 0. I will pick up pretty much traditional values. Pi over 6, pi over 4, pi over 3, pi over 2. Okay, and the highest value is 2 radians. And then I will put that into the formula for r. Don't forget to take the square root. Got 0 and 0.51, 0.61, 0.69, nice, 0.82, and finally 1.05. Okay, so generally we can see that, if the angle is increasing, the radius is also increasing. Okay. So 2 radians is about 114.6 degrees, which is just a bit above 90. All right, and let's increase the angle and increase the distance from the pole. So we'll get something similar to this. Okay, now we'll have to find in the exact form the greatest distance of a point from the pole, and that's, according to our sketch, is going to happen when the angle is 2 radians. So the distance is going to be r of 2 square root of inverse tangent 2 over 2, which is 1. So that is the square root of pi over 4. Or let's give it as root pi over 2. Okay, next question is about the area, and to find the area, we'll have to integrate. The area will be a half times the integral from 0 to 2 r squared d theta. And we have a formula for r squared, so we'll have to integrate from 0 to 2 inverse tangent theta over 2 d theta. Now, if you want to check the formula sheet, and unfortunately there's no integral for the inverse tangent, and that's probably why the question is worth 5 marks. Now, how do we integrate the inverse tangent? We can actually use integration by parts. So let's take the formula first. The integral of u derivative v equals to u times v minus integral of switch to derivative, v derivative u. Okay, but now the biggest question is, where's the second function in our integral? There's only one, negative tangent. And that's the case where I can actually sneak in 1. I will say my integral is 1 times the inverse tangent. And now we'll have to find out where it's going to be u derivative, where it's going to be v. U derivative and v. Now, again, if we look at the formula for integration by parts, we can see that we should find v derivative, and we'll actually have to integrate u derivative to get u. So that means u derivative should be easy to integrate, and v derivative should be ideally more or less easy to differentiate. Okay, we've already seen that we cannot really integrate inverse tangent straight away, so that's a bad choice for u derivative. And instead, I would say that v equals to inverse tangent of theta over 2, and u derivative is going to be equal to 1. Okay, so that means let's integrate u derivative with respect to d theta, so u equals to theta. Now, derivative of the inverse tangent, we can look it up in the formula sheet if we don't remember, but it's going to be 1 over 1 plus x squared, and in our case x is theta over 2, so this is squared. Then don't forget to use the chain rule, so we have to multiply it by the derivative of theta over 2, which is a half. Okay, so let's simplify that a little bit. We'll get 4 over 4 plus theta squared. All of this times a half. So all in all, we've got 2 over 4 plus theta squared. Okay, good. Now, let's go back into our integration. We got a half. Then, using the formula for integration by parts, first we got u times v. So it's going to be theta times inverse tangent, theta over 2, minus the integral of 2 theta over 4 plus theta squared. of course, d theta. Okay, now, how do we integrate this? Right, for that, we'll have to recall the formula. Integral of f derivative over f is equal to natural log of f. Okay, now, let's check the derivative of the bottom. 4 plus theta squared derivative is going to be 2 theta. So we don't have to modify anything. We already have that the top equals the derivative of the bottom. So that means we can apply the formula straight away. We get a half times theta inverse tangent theta over 2, okay, minus natural log of the bottom 4 plus theta squared. Okay, we're done with integration, and now we'll have to substitute the limits from 0 to 2. Okay, let's substitute the upper limit. We got a half 2 inverse tangent 2 over 2, which is 1, minus log 2 squared is 4, plus another 4 is 8. So that's the upper limit. Take away what we got when I substitute the lower limit. First, theta is 0, so the first term will be 0. And we got log 4. Okay, time to simplify that. So it's a half pi over 2 minus okay, I can actually write 8 as 4 times 2 and apply laws of logs. So it's going to be minus log 4 minus log 2 now minus and minus will be plus, so get plus log 4, and that cancels out. So all in all, we got a half pi over 2 minus log 2. Or we can expand the brackets, and finally we get pi over 4 minus a half log 2. So that's going to be the final answer. Okay, next question. Again, we'll have to use the sketch. Let's quickly do that. That's the pole. That's how the curve roughly looks like. And now we're talking about the half line theta equals to pi over 2, which is a vertical line. And we're looking for the furthest distance from the half line. So it's going to be somewhere at this point. Now, the distance from the pole to any point is given by our equation. This is small r. And I will call that distance r, a big R. Okay, we also have angle theta. It's somewhere here. Now, if we look at this, then we have some parallel lines in our picture. And that means we have alternate angles. And the angle between big R and small r is going to be also theta. And that gives us a chance to express big R in terms of small r and theta using some basic trigonometry. So r will be small r times cosine theta, because it's adjacent to the angle. Now, let's replace with the formula. It's going to be the inverse tangent of theta over 2. Take the square root, and I'm going to use indices times cosine theta. Now, it's very important in the next step not to confuse this -1 with indices. Yeah, remember, this means inverse, not the power of -1. Okay, we're looking for the furthest point from the half line, so it means r should be as big as possible. So we're looking for our maximum. And to find the maximum, we'll have to use, of course, our differentiation again. So basically, we'll find the derivative of r and then set it to 0. Right. If we look at the formula, again, we have the product of two things. So we're going to use the formula for the derivative of a product. I will say that the first bracket is u, and then cosine theta is going to be v. Now recall the formula for the derivative of the product. uv derivative equals to u derivative v plus v derivative u. And now our goal is to just carefully use the formula. Okay, let's go with u derivative. That's quite a lot of chain rules. So first I'm going to differentiate the power of 1 over 2. So it's 1 over 2 inverse tangent theta over 2, and then subtract 1 from the power. I got minus a half times, we're slowly getting inside, like derivative of the inner function. Derivative of the inverse tangent, we've seen that before already in this question, 1 over 1 plus x squared, which in our case is theta over 2, so theta squared over 4. Now we differentiated the inverse tangent. Now, going even deeper, I will have to differentiate theta over 2. That is a half. So all of this mess is basically derivative of u. So that's u derivative. Times v, that's easy, times cosine. Plus v derivative. Derivative of cosine is minus sine. So let's erase plus and put minus in there. Minus sine theta times u. V derivative times u. So again, inverse tangent theta over 2 to the power of a half. And that should be equal to 0. That's a very long equation. Okay, let's try to simplify it a little bit. And we're going to start with the fractions where we got u derivative. Okay, let's put them together, and we got 4. Cosine should be on top. At the bottom, we got 2. Square root of inverse tangent theta over 2, and we also got 4 plus theta squared, and we got another 2. Next, minus sine theta, this one is a little bit easier, times the square root of inverse tangent theta over 2, and now that equals to 0. Okay, for the fraction on the left, we can also cross out 2 times 2 is 4, 4 on top, so that also simplifies. Okay, now let's multiply everything by the denominator, and we'll get, what do we get? Cosine theta minus sine theta times square root and square root will cancel out. Yeah, becomes square root squared. So it's the inverse tangent of theta over 2. We also got 4 plus theta squared. Okay, and all of this equals to 0. Is it something close to what we had to show? It is very close, apart from the fact that we have to multiply by minus 1. So let's do that, and we'll get theta squared plus 4 times the inverse tangent times sine theta, okay, and then minus cosine theta equals to 0. That's exactly what we had to show. Our question says, verify that this equation has the root between 0.6 and 0.7. And to do so, let's substitute 0.6 into our equation. and see what we got. So it's 0.6 squared plus 4 times inverse tangent of 0.3 times sine 0.6 minus cosine 0.6. And if you substitute it in the calculator, you'll get minus 0.11, which is smaller than 0. If we substitute 0.7, let's do that. Sine 0.7 minus cosine 0.7. That will be approximately 0.21, which is bigger than 0. Okay, so if theta is 0.6, the left side of the equation is less than 0. If theta is 0.7, the left side of the equation is bigger than 0. So that means that somewhere in between 0.6 and 0.7, the left side must be exactly equal to 0. And we'll have to write this conclusion, although we don't really have enough space. We'll just put it here. And I will say that, therefore, change of the inequality sign indicates the presence of the root. Okay, next question is really standard. So find the set of values of k for which the matrix is not singular. And a singular matrix basically means that the determinant of the matrix equals to 0. And okay, how to find the determinant of 3 by 3 matrix? That's going to be, okay, determinant A equals to 1. And that's a very standard procedure. So just cross out those columns and find determinant of, oops, sorry, not plus, of the remaining matrix, K, 6, 8, 9. Then we have to alternate plus and minus sign. Okay, cross out 2. We got 4, 6, 7, and 9. Don't forget to alternate the plus and minus sign. Finally, cross out 3. 4, K, 7, 8. Okay, and then just keep going. So it's going to be 1 times 9k minus 48. So if I go in this direction, I take it with a positive sign and I multiply. Then if I'm going that way, it's always minus. So 9k minus 48 minus 2 times 36 minus 42 plus 3. Again, I'm going that way, multiplying 32. Now multiply this way, take it with a minus sign, so minus 7k. Okay, simplify 9k minus 48 plus 12 plus 96 minus 21k. That becomes minus 12k plus 6. And that should not be equal to 0. So that means k should not be equal to 5. That's the answer. Okay, next question is about finding the inverse of a 3 by 3 matrix. And to do so, I'm going to use the method of cofactors. And what a cofactor is, it's kind of similar to finding the determinant. Basically, that's the matrix that you got when you cross out a row and a column. Okay, so first of all, I'm going to cross out 1. And I get k, 6, 8, 9. So it's going to be the element of the first row and the first column of cofactor matrix. So it's k, 6, 8, 9. And later I will have to find the determinant of that. But for now, let's move on to the element of the first row and the second column. So it's 2, I'll have to cross it out. And I get 4, 6, 7, 9. That's going to be the next element of the cofactor matrix. Let's move on. I will have to cross out 3. I get 4k, 7, 8. And then I will just have to continue doing crossing out and writing down what is remaining. So next step, cross out 4. What remains is 2, 3, 8, 9. 2, 3, 8, 9. I will speed up a little bit at this point. 1, 3, 7, 9. Next is going to be 1, 2, 7, 8. Then 2, 3, k, 6. 1, 3, 4, 6. And finally, we get 1, 2, 4, k. Okay, next. I will have to alternate plus and minus sign next to each matrix, starting with a plus. So get plus, minus, plus, minus, plus, minus, plus, minus, plus. But that's not it. I will take this as the new matrix, of course. Then I will have to transpose this matrix, which means each row of a matrix becomes a column of a new one. But that's not it. To find the inverse, I would have to divide each element by 1 over the determinant of the original matrix. And finally, when I do all these steps, I will get the inverse of the matrix. But luckily, we're only looking for the top row of the inverse. Okay, so the inverse is going to be 1 over determinant A. We actually did that in the previous question at this step. Minus 12k plus 16, and I just write it as 16 minus 12k. Now, I'm going to transpose the matrix. Again, each row should become the column. So first row now becomes the first column of the matrix. So it looks like k, 6, 8, 9, 4, 6, 7, 9. Then 4, k, 7, 8. Now the second row becomes the second column, and I got 2, 3, 8, 9. Next one, 1, 3, 7, 9. Actually, don't forget about plus and minus. So it's plus, minus, plus, minus, plus. 1, 2, 7, 8. Minus. And finally, the third row now becomes the third column. And I got 2, 3, k, 6. 1, 3, 4, and 6. 1, 2, 4, k. Okay, now we're looking only for the elements of the first row. So that should be, I'm looking for the determinant of the first cofactor. It's 9k minus 48. And don't forget, we have to do multiplication by 1 over 60 minus 12k. So it's 60 minus 12k. I forgot k. 12k. Next, I will get 6 over 60 minus 12k. And finally, that is 12 minus 3k over 60 minus 12k. Okay, that's it. That will be the answer. All right, next question about matrix multiplication. Give an example of a matrix C such as BAC equals to 21k4. And I'm going to start by multiplying B by A first, and just see what I get. So B is 1, 0, 0, 0, 1, 0, and A is 1, 2, 3, 4, K, 6, 7, 8, and 9. Let's multiply these matrices together. First of all, I almost start with thinking about the dimension of the result. The first matrix has dimensions 2 by 3, and the second one 3 by 3. Okay, now cross out the inner numbers, 3 and 3. And what is left is the result of, it's basically the dimensions of the resulting matrix. So our result should have dimensions 2 by 3. 2 rows, 3 columns. Just like that. Okay, and now let's start multiplying and think about this element first. I have to multiply the first row by the first column. 1 times 1 is 1, and the rest is going to be 0, and I'll have to keep adding up the elements, so it's going to be 1. Okay, let's think about this one. The first row of the first matrix times the second column of the second matrix. So basically I'm trying to do like this times that, and I keep adding. So 1 times 2 is 2, and the resulting, like the rest elements are going to be zeros. So I get 2. And so on and so forth. I will have to try to get the next element. 1 times 3 is 3, the rest is 0, so we get 3. And so on and so forth, so I got 4, K, and 6. Okay, so that's B times A. Now, 1, 2, 3, 4, K, and 6 times something must result in 214K. First, let's try to think about the dimensions of the matrix. The first one has dimensions 2 by 3. Okay, and the result has dimensions 2 by 2. Right, so this matrix that we are looking for should have dimensions 3 by 2. So this way, if I cross out the inner numbers, my result is going to be a 2 by 2 matrix. Right, so let's draw this matrix. 3 rows, 2 columns. 1, 2, 3, 4, 5, and 6. Okay. Oh wait, is it 214K? Is 21K4? I'm really glad that I noticed. K and 4. Okay, now let's try to think about this. So first of all, I kind of feel that it's really suspicious that I got 2, 1, 4, and K on the matrix on the left, and it should stay the same way in our result. And also it looks like we're just getting rid of 3 and 6. So what I'm thinking is let's try to put 0 and 0 here. Now, in the result, I should get K, so maybe I will put 1 in here. And 1 on top. Okay, let's check. So I'm trying to get this k. That means I will have to multiply the second row of the first matrix by the first column of the second one. So I will get 0 plus k plus another 0. Yeah, so I actually get k. Good. And in a similar way, we can conclude that this one should be 1, and that is 0. Let's check it one more time. Yeah, looks correct. So I will state 0, 1, 1, 0, and 0, 0 as the final answer for that question. And the very last question is about the invariant lines through the origin. So what it means is that you got a line, such as if there is a point on this line, then after the transformation, the point can move somewhere, but the point after the transformation must still remain on the same line. So let's say that our line of invariance is in the form of y equals to mx. It should be plus c technically, but we know that the line must go through the origin, so that means the y-intercept is 0. So y equals just mx. Let's say that initially our point has the x-coordinate of x and y equals to mx, so the y-coordinate is going to be mx. And then after the transformation, this point goes to some other place. Let's say it's going to be x, the big X, and the y is going to be the same gradient times x. Okay, now let's apply this transformation given by the matrix 2, 1, k, and 4. And let's apply this to some point with coordinates x and mx. Let's multiply this matrix. So the first one has dimensions 2 by 2, and the second one is 2 by 1. So that means our result should be a 2 by 1 matrix, of course. When I multiply these matrices together, I've got 2x plus mx, and then kx plus 4mx. So the first coordinate is going to be my big X, and the y-coordinate is going to be m times big X. Okay. So that means kx plus 4mx, this is y-coordinate, equals to m times big X, which is 2x plus mx. Okay, now let's expand the brackets and see what happens. We got kx plus 4mx equals to 2mx plus m squared x. Now we can divide both sides by x, and we get the quadratic equation on m, so m squared minus 2m minus k equals to 0. Now remember, we're actually looking for m, so that means this quadratic equation must have two solutions. Let's write it down. So must have two solutions for m. Or m. Okay, so that means that b squared minus 4ac should be bigger than 0. Now a equals to 1, b is minus 2, and c equals to minus k. So that means b squared minus 4ac should be equal to 4 plus 4k. And that should be bigger than 0. So 4k is bigger than minus 4, and then we divide both sides by 4, and we get k is bigger than minus 1, but also don't forget that our transformation matrix should not be singular. So that means the determinant of this matrix, determinant of the transformation matrix should not be equal to 0. Okay, let's find the determinant. It's 8 minus k should not be equal to 0, so minus k not equal to minus 8. That means k is not equal to 8. Okay, now that's the final answer for this question. K is bigger than minus 1, but k is not equal to 0. And that's the final question of this paper. Hope it was helpful. Bye!